Hello, I'm Mr. Dady, and today we're going to talk about polynomials. In particular, how to group them by category and adding and subtracting. So the first thing you need to know is that there's basically the three you need to know is there's a monomial, binomial, and trinomial. All right? Polynomials are all expressions. There's no equals to them. All this is going to be showing you is basically combining like terms, is what you're learning here. So a monomial is just one term. And that would be something like 2 or 3x or 4x squared. All right, those are all just monomials, just one term. A binomial has two terms. So 4x plus 2 or 5x plus y, those are binomials. They have two terms in them. And if you can guess, monomial 1, binomial 2, you keep adding, what is it? Trinomial, which is how many? 3 terms. There you go. And that's stuff like a quadratic. So x squared plus x plus 4 or 3xy plus 2 plus 3y. All right? Those are trinomials. All right? Those are classifications of them, and now we're going to add and subtract them. All right, this is our first problem. All right, we just want to simplify this. So to add and subtract them, this is again my method of how I do it. I like to start with the first one, and then I just go down the list. So I have an x to the first power. Is there another variable on here that is x to the first power, and that's it? Yes, that 3x. So I take that 3x, and I put it underneath with its sign, underneath the 2x. Cancel it out. Now I move on to my 4. This is actually x to the power of 0, but it's just 1. So we'll just say for this case, that's a constant. Is there another constant in this? Yes, -6. Right? It's -6. Make sure you add that with it. So then you just add. So 3x, or just combine them. So 3x plus 2x is 5x. 4 minus 6 is -2. That is your answer. And that's how you simplify it. Basically, you're just looking for at the degrees of the polynomial, so this is x to the first, x to the first, and then you cannot combine this and this. Those are two different things with two different degrees of the polynomial. Okay, this is our second example. This might look a little bit more complicated, but if you stick with the same method that I showed you before. So we start at the beginning. P squared, or p to the second power. Do I have another p to the second power anywhere? No, that's p to the first. That's a constant. P to the second power. I'm going to put a box around the whole thing so I don't mess it up. So -3p squared. And then I cross it out. All right? Do I have any more p squared? No, I do not. Move on to the next one. Plus 2p. So I have a p to the first power. Do I have another p to the first power? No, that's a constant. Yes, I do. Then I cross it up. And then the last one is plus 6. And plus 6 is a constant. Do I have another constant? Yes. It'd be -2. Now, I just combine them all. So -3, there's a 1 in front of that. It's an understood 1. They just don't write it in. So that gives me -2p squared. 2 and 2 is plus 4p. 6 minus 2 is plus 4. Now, a common mistake here, especially if you just dealt with exponents, is you want to add these exponents together and give me p squared, give me p to the fourth there. No, you're adding. You only add exponents when you multiply. And that is your answer for this one. Example number 3. We're going to do the same method. So start at the beginning. Y squared. Is there another one that's just y squared? You might think this is, but it's not. Why? Because it's an xy squared. That is completely different. If you need to see an example, so if I say x is equal to 2 and y is equal to 3. Right? So if I plug 3 into y squared, I get 9. But if I plug 2 and 3, I get 18. All right, those are two very different answers. They have to be exactly the same. So I have y squared here. So do I have another just y squared? No, 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 yes. Negative y squared. Then I move on to my next one, xy squared. Do I have another xy squared? No. Yes, I do. Negative 3xy squared. And now our last one, x to the first power. Do I have another x to the first power? No, I do not. So what I do is I just bring that down to the final expression. So then I just combine 3 minus 1, 2y squared. Negative 3 plus 1 is negative 2xy squared. And that is your answer. All right, our last example. Now I'm going to get a little bit tricky on you. So we start at the beginning. X to the first, y to the first. Do we have another x to the first and y to the first? Yes. Now they might not look exactly the same, but they have the same exact variables and the same exact exponents. All right? So this is the same thing as this based on the commutative property. So these are the same thing. Now if you want to rewrite it when you put it underneath it, that's fine. Because this and this are the same exact thing. Let me go to our next one. X to the first. Do we have another x to the first? No, yes. Put a box around it, bring it underneath. And lastly, y to the first. Do we have another y to the first? No. So what do we do with it? We bring it down below the equation. So 1 plus 1, 2xy. Those cancel out, plus 4y. And then we'll just bring it together. 2xy plus 4y. And that is your answer. Just make sure that you understand the commutative property and that they can be switched. You're really just looking at the degrees here. That's it for polynomials, adding and subtracting. I hope you understand it, and good luck.